Let me introduce you to Dr. Krishna Sudhir. Dr. Sudhir has done his MD from the University of Madras. He's also done his PhD from the Monash University in Australia. And he has a lot of teaching experience as well. He has taught in Australia, in places like the Baker Heart Institute, and he's also taught in the Alfred Hospital. Then he moved to the United States, where he did a fellowship in cardiology from the University of California in San Francisco. And subsequently, he moved to the industry. So it's a very interesting shift that one sees from a medical doctor to a teacher to industry. And in the industry, he was involved in several research projects. He's filed several patents. He's been awarded several patents. And now he's in a leadership position in one of the world's topmost healthcare companies, Abbott Vascular. Sudhir is one of the leading cardiologists in the world, and he's responsible for the design of the next generation of stents in Abbott. He's also a teacher. He continues teaching, where he teaches as a visiting professor at Stanford University and the University of California at Berkeley. Sudhir, incidentally, is a TED Ed speaker, and we'll talk about that too. You all must be knowing about TED Talks. There's a division of TED called TED Ed, and he basically speaks there to talk about various aspects of health, heart and other aspects, including aspirin and for the public. And another very interesting part of him, which he's developed a few years ago, is his passion for writing and the creative side. So he's also an author, and he's published a trilogy, fiction books, and we will talk about that also as we move forward. On a personal note, Sudhir and I know each other for the past 50 years, 50 years, half a century. We were schoolmates. We've seen each other grow over the years. We've remained in touch. And Sudhir is a brilliant orator also. And you will learn a lot from him in today's session. Very multifaceted personality. Thank you so much, Dr. Krishna Sudhir, for joining us today in a conversation. And on behalf of Navrachana University in Vadodara, India, I welcome you very warmly to our university. Even though it's virtual, it's a very warm welcome.
Thank you, Nilay, and thank you for having me here. It's the joys of Zoom. I think, we are currently in the grip of a pandemic, but one thing this pandemic has taught us is that we can function very efficiently via video conferencing. I think it's been good for Zoom and Skype and FaceTime and all these media. So brought to your university by Zoom, I should say. And thank you for that very generous introduction. Nilay was an outstanding orator himself. And he and I represented our school, Don Bosco, in Chennai, went to various tournaments. And I think I still have a few trophies somewhere here that Nilay helped me bring home.
Yeah, I remember those good old days.
Exactly. Yeah. Back to you.
Okay. So, as you can see, I've seen a very interesting growth path that you've had from a teacher to industry. So can you tell us something about your teaching experience, and that too in Australia?
Sure. So I left India shortly after graduating from Madras Medical College, and two of my classmates, Dr. Sanjeev and Dr. Arif Swaminathan, are on this call. So I made my way to Australia at that time to do some research. I did a PhD at the Baker Heart Research Institute, and then moved over next door to the Alfred Hospital to complete my clinical training. Got involved with teaching activities at Monash University in the beginning, just teaching medical students how to examine patients and so on. And that gradually evolved into teaching residents. And then when I came to the US, I continued that teaching of cardiology fellows and so on. Having completed all my training, I was obviously associated with universities all along. I happened to be in the Bay Area. I graduated in cardiology from the University of California, San Francisco, also known as UCSF. I stayed on faculty there for about 7 years. and again taught medical students, residents in general medicine, and then fellows in cardiology. UCSF in the mid-90s had a merger with Stanford University, not at the university level, but at the hospital level. So for about 3 years, the University of California Hospital and Stanford hospitals functioned as one unit. So having an appointment at UCSF brought me down to Stanford. That's where really my passion for innovation started, because Stanford, as you know, has a long history of innovation. I came into contact with many bright engineers, chemists, scientists, and so on, started chatting with them, and eventually made the move to industry from there. So there was teaching at the Baker Institute, there was teaching at the Alfred Hospital, there was teaching at UCSF, and there was teaching at Stanford. And eventually, the last of those experiences, the Stanford experience, was what brought me to industry.
Okay. So you made a very smooth shift to the industry, as one can see. So how did you find this difference between industry and education?
Yeah. So, training as a cardiology fellow and then being on cardiology faculty, first at UCSF and then at Stanford, I came into contact with lots of people from industry, both on the pharmaceutical side as well as the medical device side. And both of them intrigued me because as physicians in practice, we know about medications, we know about devices, but we're not that familiar with the pathway that creates them. So how is a drug discovered? How are a molecular compound screened? How do you choose the right one to dose a patient with? How do you start a clinical trial? What are the phases that the drug goes through? Phase 1, phase 2, phase 3 in drug trial research. And then on the medical device side, as physicians, we implement these devices. So as a cardiologist, I was in the cardiac catheterization lab. I was around colleagues who were implanting stents, implanting pacemakers, using balloon dilatation catheters to open up coronary arteries. So I was curious about how these were originally discovered, how patents were written for them, and then how startup industry got involved, how they were developed, how they moved to the larger companies, and how they became commercialized from there. It was all a big black box for me. I had no concept of how this was done. So initially it was curiosity. I was offering advice to people from industry, but never really participating in drug or device development. So I wanted to make that transition, and being a physician in the Silicon Valley made that transition relatively easy, because in the Silicon Valley, there are a very large number of high-tech and biotech industries, as you know. There's probably, I haven't counted recently, but estimated to be about 1,000 biotech industries between Santa Rosa up north and San Jose in the south. Some of these are small garage operations of 3 to 5 people. Some of them are, larger startups, and they grow in size and eventually become acquired by a bigger company. So my transition in 2001 was joining one of these startups. I worked at a couple of them. I gathered some basic experience. I learned a lot about not just industry. I don't have any background in finance, for example. I don't have an MBA or a finance degree. So I was surrounded by people who knew this stuff much better than I did. So I learned from them how to raise capital in efforts like this, how to present to people who are not necessarily in your field. This is something that some physicians do well, some don't do that well, because medicine and science are complex. So how do you actually present the arguments to lay people in order to get them to partner with you in your enterprise, whatever that might be? So it was a very interesting voyage of discovery. So after 2 startups, I worked for 3 years at Johnson & Johnson, and for the last 14 years, I've been at Abbott, initially running clinical trials, and now heading global medical affairs in a division within Abbott.
So have you noticed, one of the things that one finds, the difference between academia and industry with respect to research is that in academia, you are encouraged to publish to the outside world. In fact, you are supposed to publish, especially in tired journals. Whereas in industry, the focus is more on patents, which kind of narrows down the reach of your discovery.
Yeah, it's an interesting distinction, but it's a but I think the two areas are getting closer. And one of the reasons for that is a lot of academics have started to patent. And in industry, since industry started hiring people like me, not now, but 20 years ago, we encourage our scientists and our physicians in industry to publish. So I continued to publish after the move from academia to industry. But in a sense, I regret having published a lot in academia without actually patenting some of those interesting observations, because then somebody else profits off something that you have discovered. So since a lot of students are listening to this talk, my message to them is, think about both sides of the equation. Publications are important to get it out, but once it's in the public domain, it's very hard to patent it. So if your university has patent attorneys or you have access to them, talk to them first. And sometimes you can just file a provisional patent very quickly and then still, submit the abstract for presentation, present it. The publication path takes, 6 months, a year, 18 months sometimes anyway. So if you file your provisional patent up front, you're kind of protected as you go along. Many of you don't know this, but Albert Einstein started his career at the Zurich Patent Office. And he was very big on patenting, because when he was a young 26-year-old thinking about, E is equal to MC squared and other things, he actually had a day job in the Zurich Patent Office. So he was very aware of this. And when he taught at Princeton, this is what he taught his students. You may have a fantastic discovery, but if you don't patent it, you don't own it. And that's fine if you are of the view that it should belong to the world. But if you think that you should get credit for it and eventually profit from it, then you need to patent it. In fact, there's a famous story of Watson and Crick presenting the double helix DNA model at Princeton, and turned out that there was an elderly gentleman with long white hair in the audience, and that was Albert Einstein. And he raised his hand and he only had one question. Okay, you guys have discovered DNA. Can you patent it? Turns out, it's something made by God, right? You can't patent it. That was the answer. But he wanted to know if it could be patented or not. That was the only question he had, that he posed to Watson and Crick.
Okay. So
that's
very
the story.
interesting.
Yeah,
interesting. Okay, my next question is the experience, because you continue to teach even today.
Yep.
You're a visiting professor at Stanford and Berkeley. So how has your experience now in industry kind of helping you to teach and connect with the student community?
Yeah. So industry is a very broad term, right? So, and I didn't know this before I actually joined industry. So in industry, we have a number of departments in a company. So a big company like Abbott or Genentech or Merck or Bristol Myers Squibb, there's the research and discovery arm, where you have a lot of extremely smart scientists who are creating, discovering, reading the literature all the time, bringing new things in. In the COVID context, for example, people are making new tests every day, making antibody tests, working on antiviral agents, working on eventually a vaccine. So hopefully some of these brilliant minds will get us out of this pandemic and so on. Then the next thing is, once R&D has made the product, then they throw it over the shelf to the clinical guys who can test the product. Actually, there's a preclinical group first that may test the product on the bench and in an animal model. And then there's a clinical group that tests it in humans. There's a regulatory group that is constantly talking to the FDA or the regulators in India or the regulators in China or Japan and Europe and so on, so that when the product moves along its life cycle, it can come through the approval process. And then once it's approved, you throw it over the fence to the commercial guys who can then scale it up and then bring manufacturing in, so that you probably made 200, 500 of these products for your clinical trials, but now you need 5,000, 10,000, 100,000, 1 million of these to commercialize. So you have to be talking to manufacturing people who can scale it up and then take it to full production. So that's the breadth of industry. Generally, physicians and scientists stay in that first part of the equation. We're on the R&D and clinical side. We're talking to the regulatory guys. We're talking to commercial guys. We're talking to manufacturing guys. But our comfort zone is in that R&D and clinical space. And that's where hopefully we make our contributions in the commercial and R&D space. So when I go and teach at Stanford or at Berkeley, at Stanford, there are more tutorials. I teach young cardiology fellows from all over the world, occasionally talk to bioengineering students. At Berkeley, I do classes to the graduate school in bioengineering, and they're interested in knowing how concepts evolve through, the industry life cycle and actually become realities. So a concept starts with, a drawing on the back of a napkin, and then you develop this product concept. You shouldn't forget to patent it, otherwise you don't own it at all. And then you take that through, you probably make a few prototypes, you test it on the benchtop, you test it in an animal model, and at some stage, given with all the quality controls in place, you're ready to transition to a human experiment, if you like. This is true of drugs, this is true of a variety of medical devices and so on. So that's now my area of expertise. I spent many years in academia where I did completely different things. I was looking at risk factors for cardiovascular disease. I looked at high blood pressure. I looked at hypercholesterolemia. I looked at antiplatelet therapy, looked at a variety of things. And we were going to talk about TED-Ed videos later on. A lot of my TED-Ed videos are around those topics, sort of the traditional cardiovascular medicine topic. But increasingly as a teacher, interestingly, at Stanford and Berkeley and other universities, when I get invited, they want me to share my experience of a physician in industry. When I joined industry, there were only a few of us around. It's getting more common because industry has learned that hiring physicians is a good thing. We are people who've been in the trenches. We have treated patients. We've looked after patients. We have a better idea perhaps of what patients need. So having a medical consultant within the industry framework is sometimes a benefit. So it's a long answer to your question, but essentially the focus of my teaching tends to be these academia industry collaborations, right, and how a physician in industry actually contributes to the development of products within industry.
Okay, right. In fact, now we move to the next part of our conversation, which is very much connected to the academia industry interface. And you have actually witnessed and have been a part of the entire innovation engine that you see in the Silicon Valley. So would I be kind of right in saying that one of the first component of the secret sauce of innovation in the Silicon Valley is academic industry interface?
Absolutely, absolutely. So I was lucky, oftentimes in life, your path is directed by circumstance. So in the early 90s, I came to UCSF to do my cardiology fellowship and stayed on for an extended period of time. And I found myself, by virtue of coming to UCSF in the Silicon Valley. So you're surrounded by tech companies, you're surrounded by biotech companies, and you go to a barbecue on a Sunday. I mean, these are guys who invent stuff and patent stuff and, are doing interesting stuff like this all the time. So it's a very exciting milieu, a very exciting environment. Now, there are a number of reasons why the Silicon Valley is extremely successful at what it does, why it produces, in the high-tech sphere, Google and Facebook and, WhatsApp and, 1,000 tech companies. And on the medical side, produces companies like Genentech and Gilead and Abbott and so on, which have really contributed a lot to the world. I think, though, you said it, the crux of what makes the Silicon Valley different is there is a very close juxtaposition of three things. It's academia, industry, and investment capital. So let's say you want to launch a startup company, and some of the people in the audience have probably done it. You need the idea first. The Silicon Valley has three major universities: Stanford, Berkeley, and UCSF. So UCSF and Berkeley at the north, Stanford in the south. We have others as well, like Santa Clara University and so on. So there is a wealth of intellectual capital. These are bright people, bright students who come out of these universities. For example, Hewlett and Packard came out of the dorm in Stanford. Larry Page and Sergey Brin, who launched Google, came out of the dormitory at Stanford. In fact, I think they wrote their original patents when they were students at Stanford, and they wrote it when they were, together in the dorm. So that's the first thing, academia. The second is industry. There are, 1,000 biotech companies and several thousand high-tech companies in the area. The third is investment capital, because people need to be ready to invest. So there is a street in Silicon Valley. It's very close to Stanford. It's called Sand Hill Road. Some of you might have visited. Sand Hill Road has about, I don't know, $4 to $4.5 billion in investment capital that people are willing to dole out to good projects, right? So you might have to go to the big equity banks on the East Coast, but you can probably raise a lot of capital here in Sand Hill Road. So for a guy who wants to do a startup, or a woman, I don't want to be sexist here, for an individual who wants to launch a startup, we've got the perfect confluence of the three. You've got the ideas coming out of the university, you've got the companies and the milieu to actually create the company, and you've got the investment capital with very smart venture capitalists who kind of can put the finger on what's likely to succeed and what's not. I presented many times to these guys, and you start the conversation going some way, and when you come out 60 minutes later, you say, oh my God, he pushed me in a completely different direction that I was never thinking about. And it's because they've done it for the last 20 or 30 years, and you can benefit from their experience.
Okay. The next point I'd like to discuss here is the second point of the secret sauce of innovation in the Valley, which is the ability of people to think out of the box. Yes. So can you give us examples from different industries like IT industry, biotech industry, Hollywood?
Sure.
And even
about thinking outside the box. Yes, of course. Yeah, so that's a very important component here. You may have challenges that you're facing, and you have to be in a certain mindset to solve that problem, right? Einstein said you can't solve a problem if you're in the same mindset you were when you created it. So you have to learn to think differently. And there are many, many examples of this. If you think of the Apple Macintosh computer, right, that was designed by Steve Jobs and Wozniak. I mean, it was a little skunkwork project within the big Apple setup, within the big Apple environment. And they had this little project where they're going to create this little box, the original Macintosh computer, given a little funding. It was thought to be a side project. And before you know, the tail is wagging the dog, right? So it was the out of the box thinking, why do we need these huge mainframes? Can we actually have a little computer on our desk? Now, this is going back to the 80s. Think of Amazon. Amazon was originally a company that delivered books to your door, so it was a bookstore online, right? And the guys who created Amazon realized we had a very good thing in this delivery system. So suddenly it became larger than just delivering books. It became a delivery company. So today, books are a very small part of Amazon. Amazon will deliver practically, anything to your doorstep. I'll give you an example out of medicine, which may surprise you a little bit. A lot of discoveries in medicine are serendipitous. So there's a huge industry with, how shall I put this? Sexual dysfunction, family-friendly program, right? Sexual dysfunction. But the original drug for this, and I see Dr. Sanjeev laughing because this is his specialty. He's a urologist. The original drug was actually developed for treatment of heart disease. Okay, Viagra was developed for treatment of chest pain and angina. But the scientists who were studying these patients realized that there was an interesting side effect going on. So they had the foresight to pick up the side effect and make it the main sort of destination pathway of the drug. Another example, if you like, of out-of-the-box thinking, where you don't really dismiss something because it doesn't fit your plan. You ask yourself the question, does this other thing going on here actually make sense? And can I capitalize on this in order to move something else forward? So you may be in a completely different mindset, but if you keep your mind open to possibilities, other things may develop that may take over the world in a completely unexpected way that, was not originally intended. These accidents that happen when you're in the discovery process can actually be leveraged and converted into products that, end up being extremely valuable to society or extremely valuable to the world, depending on your approach to the problem. But you have to be in a ready frame of mind to accept it when something is not going well and you see something else is going well, to actually move in that particular direction.
And how about a couple of other industries like medical devices and Hollywood? You're very close to those places.
Of course, yeah. So Hollywood is an interesting example. So My two sons work in Hollywood and they make movies there. They might be watching on the YouTube channel. You never know. So Hollywood also, has evolved over the years. And there's one interesting example. There was a movie called Paranormal Activity, which was made on a university campus. I forget which one, about 10 years ago, maybe. And the guys on the university campus were basically having fun. They had a total budget of about $15,000 or $16,000. To give you an idea, most Hollywood budgets start at $1 million upwards, maybe even 2.5 million upwards. And an expensive movie can be 75 million, 100 million US dollars. So they had a budget of 16,000 US dollars, but they decided to make a movie called Paranormal Activity, which was about ghosts, ghosts in the building, ghosts on campus, a kind of a funny movie. So they used very cheap props like, a sheet tied to a piece of string and you drag it along and that's essentially a ghost. They advertised using very low budget advertising on university campuses. So whatever the prevailing social media was at the time, probably pre-Instagram and pre-Snapchat, so it was predominantly Facebook perhaps, putting up ads in the cafeteria and so on. And it took off on university campuses. And then suddenly at some stage, Steven Spielberg got interested. The franchise got sold, I think eventually to Paramount, and the franchise ended up being worth, close to $1 billion. So you're starting with $16,000 and ending up with such a huge franchise because people were willing to put in some out-of-the-box thinking, not necessarily go for the big budget approach, think outside the box. What can we do here within our budget and kind of make it work, Another example is this recent movie Parasite, which won the Oscar for Best Picture at Hollywood at the most recent Oscar award. This is a South Korean movie about class differences in society and so on. The director was reasonably well known in South Korea, not so well known perhaps in the United States. He put together this brilliant film about, a wealthy family and a poor family. And guess what? A year later, he's walking up there receiving the Oscar. And you have to give credit to the Academy for at least now being a little bit open to these out-of-the-box ideas and giving something that was not out of Hollywood the biggest award in Hollywood. So thank you for asking me about that.
Right. Okay. Now, another unique aspect about the Silicon Valley is about diversity. And how does diversity help spur innovation?
Yeah. So when we think of diversity, we can think of it in two separate boxes. One box is what we usually think of, and that is racial diversity, ethnic diversity, national diversity, and so on. So we are blessed in California, and to some extent in the United States. We go to New York and Florida, most of the United States, we are blessed in having a multicultural, multiracial society, right? So you have the best and brightest people around the world. But what we have learned in the Silicon Valley, and probably other people have learned elsewhere, you learn it in medical environments all the time, by bringing in people from diverse backgrounds, not only are you bringing in diverse ethnicities and diverse, people from diverse nationalities and so on, you're also bringing in diverse ways of thinking. And cross-pollination between people who have different ways of thinking, different ways of problem solving is extremely important. For example, not to throw stereotypes around, but there may be some merit in it. Maybe we as Indians are more organized, more structured, our educational system is more structured and so on. There are aspects of the US system that are less well structured, but more open to creative thinking. So you put those two together, you put a person with a background like yours or mine, where we have been structured through our schooling and our university education and so on in our bachelor's, master's, doctoral degrees, and throw us together with somebody who has completely off the wall, out of the box ideas, there's a synergy in that, because the person with the off the wall ideas may not be able to take them through to the next step because they have not learned the art of organized thinking. Whereas we've spent most of our life in a very traditional approach, learning the art of organized thinking. So you can see how that synergy can happen when you throw diverse populations of people together. So this has been recognized in the Silicon Valley. I think it's particularly well recognized in the IT industry, probably even over the medical industry and either drug or device industry. We're playing catch up. But in the IT sector, it's dominated by people who've come in from India, from China, from other Asian countries like Taiwan and Singapore, from Eastern Europe, Russia, the Ukraine, and so on. And these people have, cross-pollinated with local Americans grown up here, I guess, and created these amazing enterprises. And this has now been recognized all the way up to the top. There are 5 major companies now in the United States where the CEO is of Indian descent. You have Google with Sundar. Yeah, you have Microsoft with Satya Nadella. You've got IBM, who now has an Indian CEO. You have MasterCard, which is not necessarily Silicon Valley. It also has an Indian CEO. And you've got Adobe, which has an Indian CEO. There's probably many, many others, but these are 5 large companies in tech. MasterCard is, of course, tech and banking and so on, which have CEOs of Indian descent. So this is a recognition that bringing in diversity at all levels can really contribute to different ways of thinking, moving things ahead in a way that would not have been possible with much more homogeneous thinking. I am convinced now, and I lead a very multicultural group. I think I have 20 plus people in the group, but we probably have people from 12 or 14 different backgrounds. So that the cross-pollination that's possible with these very diverse backgrounds is pretty amazing, and has to be seen to be believed.
Right. You see, another very important aspect of the secret sauce of innovation in the Silicon Valley is the ability of the Valley to kind of not only accept failure, but kind of encourage failure. And, there are several examples, including in your industry of stents, where the Zion stent went through several iterations before it became a blockbuster. Can you tell us about this culture of failure in the Valley?
So again, those of us who are schooled in a traditional way, right? If we come from India or Singapore or Australia or Britain, countries with more traditional educational systems, you go through the motions, you try to be as good a student as you can be and so on. And there's nothing wrong in that. Academic excellence should be celebrated, of course. But the point is that educational systems have to be flexible. Just remind me of the question again, Nilay. I got a little distracted with the thought.
The ability to accept and encourage failures.
Failure, exactly. Failure. So students trained in a traditional system, the ability to accept failure is sort of very much in the background. It's almost a no-no. On the other hand, when you launch a startup company, there is probably a 9 in 10 chance, it may be even higher, that the company is going to fail. So the success in Silicon Valley, particularly in the startup world, tends to be a small percentage of the total companies that are launched. But in Silicon Valley, we accept this. We accept that failure is the stepping stone to success. So if you work for a startup that failed and move on to your next startup and your next startup, you're wearing these as badges of honor because you've learned from your prior experiences what not to do. Apparently, Thomas Edison filed thousands and thousands of patents on the electric bulb before he actually made the one that worked. So he said, if it takes you 10,000 steps to make the electric bulb, it doesn't mean that you failed 9,999 times. It means that you learned 9,999 things that you should not be doing on the way to making the one thing that works. So like I said, we have a big tolerance to failure here. So take any company that's a household name. Take Tesla, for example. The initial models of the Tesla, there were these nightmare examples of it just stopping on the freeway and, the engine cutting off and the driver not being able to drive any further. But Elon Musk, was dogged, tenacious, and they moved from one model to the next, and they made the later models successful. Take space exploration, right? When you and I were students at Don Bosco, space exploration was just starting. I mean, in the 50s, the Russians had put Sputnik into space. The Apollo program was launched. 1969, when we were young kids in school, landed on the moon, but they didn't get to the moon without some failures. In fact, there was this very tragic Apollo test flight where 3 astronauts, Grissom, White, and Chaffee, were killed. If you look at the Columbia experience in the 80s, there were at least 2 space shuttles, right, that burnt up. One, I think, burnt up immediately after launch, one burnt during re-entry. And these failures are sometimes the price one pays for very daring exploration. It's also a reflection of your propensity to take risk. In the Silicon Valley, we have a much higher appetite perhaps for risk. There is an experiment which is very interesting, and this was conducted on a colony of baboons in a university on the East Coast, which studies behavior in baboons, and they're very similar to us humans. They taught these monkeys on a computer to pick a red dot or a green dot. Now, if they hit the green dot, they got a jelly bean very reliably. You hit the green dot once, you get 1 jelly bean. And apparently monkeys love sweets. So, the monkey is rewarded immediately. You hit the red dot, you may not get anything. But in random fashion, maybe on the 27th try or the 49th try, you get 100 jelly beans. Okay? So this is risk-taking. And apparently the colony separates roughly 98 and 2. 98% of the monkeys go for the green dot because you want that 1 jelly bean every time. But 2% of the monkeys will choose the red dot because they want the high risk, high reward. Okay. So a lot of our Silicon Valley CEOs belong to that 2% group. They're okay with the high risk, high reward. While most of us, are probably in the remaining 98% where we, want to go step by step. And human behavior might be a combination. At certain times in your life, you're probably more of a risk taker, maybe in your 20s, and then you need to have a steady career. And then maybe, when we retire and we are in our 60s and 70s, we can come back to risk taking and do our own startups. I don't know, you see. So this is not, I don't know if it's innate or acquired, and I believe it can change in various phases in life.
Okay, right. The next point is the kind of structure of the organizations which are there in Silicon Valley. Very unique structures as compared to the older industries, the smokestack industries. Right. We find them absolutely no hierarchy, yep. Teamwork, and that in turn results in so much of innovation, not just in IT industry or biotech industry, but even companies like Pixar, which have yes. managed to come out with blockbuster movies. Yes. Yeah. But the structure of the organization is extremely flat. What do you have yep. to say about that?
It's an extremely important point. So generally, the smaller the company, the less the hierarchy. And you find that as the companies grow in size, when they become acquired, when they start to be merged and brought into the larger organization, you see more structure and more hierarchy. But in the startup environment, anybody can talk to anybody. So the junior most engineer in the company is often able to talk to the CEO because these companies might only have 10 people or 50 people or 75 to 100 people. So I think that free-flowing dialogue between junior people, mid-level managers, and senior people is extremely important to move an idea along rapidly. In Pixar, apparently, there is a rule that before the final cut is done, you have to make sure that you've read the notes of everybody who's been involved in the project. And one of the reasons their movies like Ratatouille or Coco or, their movies are so successful, the whole Toy Story series, is probably because of this attention to detail where anybody can point out anything during the process of making these movies. And I think that's what ends up with such a successful product. We see that a lot in the R&D sector in the Silicon Valley where, there's free flow of communication. You see iterations much faster. You see modifications of ideas so that you may have 6 people coming at it from 6 different angles, but then they talk to each other very quickly, get the idea moving forward, and then you can go on to the next step. So I think it's important. You need some hierarchy when you get to a more advanced level of a company because now you're starting to deal with regulators, you're planning commercialization, you have to think about manufacturing and scaling up and so on. But at the early stages, you really don't want these hierarchical approaches. You want free flow of information between people involved in the project.
Okay. Now let's move to the next part of the discussion, which is the TED Ed, which yep. you have often, and you have many videos on TED Ed. Now for the benefit yep. of the audience, all of you must have heard of TED Talks. TED Talks is a very reputed organization where they have reputed speakers who speak. And there are subdivisions of TED Talks. One of them is TED Ed, that is TED for education. So Sudhir has been, kind of speaking and preparing videos on various topics of healthcare, like, for example, a heart attack or aspirin. And these are all for the public, for the layman, what you should do, what you should not do. And Sudhir, can you tell us about your passion for kind of educating the masses about these aspects?
Sure. So briefly, a word about TED Ed. So everyone's familiar with TED Talks, as you say, but there is a division of TED that creates educational videos. And this is called TED Ed. Initially, it was targeted to high school and college students. They tended to be the major consumers of TED Ed, but it's become so popular, and I think they've got about 12 million subscribers that come from all walks of life. So a couple of years ago, I started working with them, maybe 3 years ago now, and it takes about 8 months, sometimes 10 months to create a video. So essentially, as the educator, I write a script, they assign me an animator. They assign me first an editor who works with me on the script, then they assign an animator, they hire a voice actor to do the voices, and then we put the production together. So it's like creating a movie. They're only about 4 or 5 minutes long. The first one I did was heart attacks, and then, as you said, I did aspirin. I did one on smoking and the benefits of quitting. I'm currently working on one on yoga, which will be released in the next couple of months, that has a lot about the discovery of yoga in India and the health benefits of yoga, something that I am a fan of and believe in. And the videos get lots and lots of views. So one thing I learned is, I speak a lot at medical conferences, and perhaps the largest audience I've had was a few years ago at the American College of Cardiology meeting, where I was presenting a new technology, and maybe there were about 1,000 people in the room. So I thought, wow, this is a huge audience. But that heart attack video has been watched by 3.5 million people. Oh. So your ability to reach people is much, much higher in this medium, social media. The anti-smoking video, I think, has reached 4.2 or 4.3 million people. I could never imagine that size of an audience in a room, right? However large the room is. Even in a football stadium, I mean, if you're speaking to people in a football stadium, maybe 85,000, maybe Eden Gardens, Calcutta would be 120,000 or something like that. But that pales in comparison to having an audience of 2, 3, 4, 5 million. And I think that's the power of social media. So something I think in this current educational environment to think about. I've been very intrigued by the TED organization and their ability. TED stands for Technology, Education, and Design. And essentially, they got very popular with the talks, but there's so many spin-offs now of the TED organization that are pretty amazing. I think they have these local things called TEDx that you can do in your neighborhood. And then these TED Ed videos happen to be a more visual component of their education. Now, I have shown those heart attack and anti-smoking videos to as young as 5-year-olds and to elderly people in their 80s and 90s. And people, they're animated videos with a voiceover and so on. And people take what they can get because the medium is so strong, right? So a 5-year-old watches it and is taken up by the animation. And something registers even in the 5-year-old mind. Obviously, somebody more mature gets a lot more out of them. But it's like watching an animated film with your daughter, Nilay. And what she gets out of it is very different from what you get out of it. But each one is getting something of value.
Right. So, in fact, the whole audience here, if you wish to, in fact, you should view some of his educational videos, like the video on heart attack or, aspirin and others. They're short videos. You can just Google. They're all open source videos. So you just kind of Google TED Ed, Dr. Krishna Sudhir, and you'll find his videos there. Very interesting videos. I've seen them myself. And it will help all of you maintain a good, healthy lifestyle. Okay, hopefully. My next point is something a little different, which is despite your busy schedule of leading a top multinational company division, your teaching interest, academia interest, you still have a passion for writing, and you write fiction books.
Yep.
I know your mother is a very famous author. She's an award-winning author, Dr. Geeta Krishnankutti, and she has received awards like the Katha Award, the Crossword Award, a very well-known translator who translates regional language literature into English. And so have you kind of inherited this passion for writing from your mother?
Yeah, I think one of the biggest gifts you get, right, is the genes from your parents, right? You have little control over that, and when it works out, in a nice way, it's pretty awesome. So Dad was a physician. I think he gave me a lot of the left brain, so to speak, with the science and the approach to problem solving and things like that. Mom was interested in literature, music, and so on. Introduced me to Simon and Garfunkel when I was in school. Her mom, my grandmother, was actually one of Kerala's first translators, and she translated in the reverse direction. She translated books like Jane Eyre, Silas Marner, Anna Karenina, the Russian novel by Dostoevsky, into Malayalam. My mother seemed to have inherited the talent and took it to a whole new level, and she translates the other way. She translates Malayalam novels into English, and as you've rightly pointed out, has a number of awards, including a Sahitya Academy Award for translation. So, from an early age, we're interested in multiple things, but one of the things that you're interested in kind of takes hold of your life. And in my case, it was science and medicine. So you get to your 50s, we're not revealing our age here, right, Nilay? You get to your 50s, and then you think, what about all these other interests that we have? What's going to happen to the music, the writing, the interest in certain landscapes? Maybe some of you like art and painting and so on. So in my case, I always wanted to write novels. I was a huge fan of reading when I was young. And as my two boys were growing up, we were huge fans of Harry Potter. So I got sucked into the world of fantasy fiction with the 7 Harry Potter novels, the 8 Harry Potter films. And I decided that my first stab at writing was going to be in the fantasy fiction genre. So I wrote a book. It's called Nujran and the Monks of Mirar. I'll do a little plug for it. It's available on Amazon. And it was published 2 or 3 years ago. And it's done reasonably well out there. And I thought I would convert it to a trilogy. I think you mentioned that at the start of the show. So I've written the second book now and submitted it for publication. It'll be out in the June-July timeframe. It's actually the sequel. So in the first book, we have a young prince. He grows up on a planet in a distant galaxy. He's a bit of a spoiled brat. And then he meets this teacher who's actually kind of like an Indian god with 4 arms and so on. He wanders around the planet with this teacher. He has brave new experiences, grows up into a young teenager through these experiences. And we leave him at the end of the first book, as this more mature teenager, if you like. The second novel starts with him on a university campus, and we follow him through his adventures at the university campus. And because I spent a lot of time at Stanford and Berkeley, and my younger son was at USC, you'll actually see features of these 3 campuses in the book that one may or may not recognize. And then hopefully in the third and final book of the trilogy, there'll be some conclusion with this individual either growing up or maybe coming back to the throne of his original of his place of origin, etc. I haven't planned the third book as yet, but the transition was interesting because in science and medicine you have to stick to the fact. Every line of those TED videos is fact checked. You can't just be like Trump, say whatever comes into your head, right? I mean, if you put out something there on the TED video, it's been checked multiple times by the wonderful fact checkers in the TED organization. Science is like that too. When you write a paper, you have some leeway, I guess, in the discussion section when you can interpret the paper, but you present the facts as they are. You present the hypothesis, the statistical analysis, the conclusion, you present as they are. Literature and fiction are completely the opposite, right? So you can go into this world of fantasy, you can create things that don't exist because in a sense, you as the writer are the master, you're the controller, right? You're creating this new universe that doesn't exist. So for me, it was extremely liberating to create an essentially new universe. And you know, you have to let your imagination wild. Living in California, we are fans of good wine. We have excellent wineries in the region and so on. So you have half a glass of wine with your dinner in the evening. You know, you're feeling mellow. Your mind is in a good position, and then you start writing. And then, you know, you just write because it's a right brain activity. It's a creative activity. And the next morning you come back to it, or days later you come back to it to edit, because you shouldn't do both of them together. You confuse the brain, you know. One is a right brain activity, one is a left brain activity. So you create, and then you come back and edit later. In fact, Ernest Hemingway said it best, but he put it rather crudely. He said, write drunk, edit sober. I don't go that far. I just, you know, half a glass of wine will do it, and then you write. Or if you get the same thing on coffee or tea, or, you know, just having a samosa may let the creative juices flow. Who knows? Who knows what does it for you, right? So that was the transition from science and medicine to creative writing, something that I've really thoroughly enjoyed. And I recommend it for all your students, you know, whatever their creative passion might be, whether it's a musical instrument, song, dance, literature, art, you know, don't let that fall by the wayside. Or if you do, because of, you know, the structure you have to go after building a career and so on, you can always return to it later in life. You know, you can come back to those creative passions later in life.
Right, right. Okay, I'd like to throw open the platform for questions from the audience.
Professor Sudhir, I have a question for you. You have been working at Abbott for quite a long time, and a lot of medicine-related innovations happen. And there is a question of intellectual property. But does this get impacted by the political pressure? So, for example, right now there is a lot of debate about the vaccine research that is going on. Although IP has a lot of provisions where government cannot interfere easily. And it is the companies like Abbott and BMS and others, probably they will come up with something. But is there a government pressure on the...
Yes and no.
Let me introduce you. Dr. Sandeep Patil is heading our chemistry department.
Okay, great, yeah. So intellectual property is supposed to safeguard the researcher, right? Safeguard the researcher, safeguard the company so that you own the property. Political pressure comes in, you know, at various levels. It may be, and it can go in both directions. It may delay the launch of a product, or it may accelerate it. You may have read that in the COVID era, because the world is really waiting for tests for antiviral treatments and for potential vaccines, chances are that the regulators are going to accelerate a lot of these and make it a little bit easier. But there have been situations where, you know, things have been slowed down as well. And it kind of depends on, you know, what's in the public's mind. I remember when I first came to the US, HIV or AIDS was very much in the in front of the public, and AIDS drugs got through much faster than drugs, say, for cancer or drugs for heart disease, because it was perceived by society that such a deadly disease should have a lot of attention paid to it, and therefore the FDA made it a little bit easier to move things forward. I don't think it affects your ability to patent, because that's a separate thing with the US Patent Office or with international patents. So that really shouldn't be affected by the situation. That depends on how the examiners view your patents and so on. But it does affect the speed at which you can bring something to the market, you know, having developed it. The political climate surrounding something of that nature. One thing we've noticed is that in the medical industry, we are always a lot slower than the IT industry, right? If you have an idea at Facebook, you can, you know, in 6 days, it could be a product on Facebook, right? Whereas for us in the medical device world, it could take 18 months, 2 years, 3 years to bring out a product. And in the drug industry, it takes a lot longer than that, because you have to do now large-scale trials. So for a blockbuster drug to come out onto the market, it could take 7 to 10 years. So there are huge discrepancies or differences at the speed to market in various different industries.
Okay.
Thank you.
I think Dr. Sanjeev Bundy, I think you were from Australia. I think Dinesh, he was trying to say something. Can you kindly unmute him?
Yeah.
Just a minute. You're muted, sir. We'll just unmute you. Dinesh, please unmute Dr. Sanjeev Bundy. Just a minute, sir. Still muted.
No problem.
Sanjeev Bundy, Dr. Sanjeev. Yeah. Yeah. Please go ahead, sir.
So, Sudhir,
Yes.
any of us in your first book?
Yeah, there's a whole range of characters in the first book. So I will any resemblance to any person living or dead is purely coincidental. That's my
No, I think I've noted about 8 people in that.
Very good, very good. You're a smart guy. Yeah, you're a smart guy. Obviously, any writer will tell you, and you're a writer yourself, Sanjeev. You base characters, places around things that you know, right? So most writers will start off with writing about environments and people they know. Obviously, you change the character, disguise the environment a little bit because you're writing fiction. But 9 times out of 10, characters that you write about in fiction may bear some resemblance to, people, situations, circumstances, places that one knows. Now you can take that to a different level, of course, by twisting and going into new areas and so on. But essentially, there's some truth in that.
They're better avatars of the same people we knew.
That's right. Exactly.
Thank you, Dr. Bundy.
Flexibility.
Dinesh, any other question?
Tejal, ma'am.
Yes, Dr. Sudhir. First of all, what a fascinating life and what an inspiring journey so far.
Thank you.
So many talents, diverse talents, so many achievements. How do you manage all of this, and what is the level of discipline that you have in your daily life? I think this will inspire us and our students. So my second question is that, Yuval Noah Harari in his book, 21 Lessons, talks about biotech. Now with COVID, of course, healthcare too, being very important in the decades that will come up. What would be your advice to a university like ours, which is preparing students and professionals for the future? What kind of courses, or where should our focus lie? 2 questions.
Okay.
Thank you.
Both are good questions. So let me start with the first question. The first question is about time management, right? So we all want to do a number of different things, but there are only so many hours in the day. Most of us need about 7 or 8 hours of sleep, so that if you subtract that from 24 hours, you have about 16 hours left. You need some time, to go to work. You need some time to eat, and you don't have a lot of time left. So I'll give you one example that might illustrate, perhaps ways of managing one's time. So as part of my job at Abbott, and I've written this in the preface of the first book, I travel around the world. There's a lot of global travel involved. I come to India, I go to Australia, I go to Europe. I'm in Singapore a lot because our Asia Pac head office is there. You have to go to Japan. So the point I'm trying to make is a lot of these are very long flights. So San Francisco, Singapore, for example, is a 16-hour flight, right? So I need 8 hours of sleep. So you have 8 hours of waking time on these flights. Maybe you spend an hour or 2, eating, and then maybe you spend 2 or 3 hours doing your work. You're creating slides for the conference you go to. You still have about 4 or 5 hours left. And most of us would watch a movie. I certainly watched a lot of movies on my flights. But then I decided when I wanted to write the novel, look, there's a lot of time to write in the sky. And it's a beautiful place to write in because you're isolated. The phone doesn't ring. It's very quiet. And you can think. So the entire first novel, and actually I'd say 90% of the second novel, was written in the air. Now because of COVID, I'm not flying temporarily. Post-COVID, it'll start up again. But here's my interesting approach to time management in that situation was, I don't have time to write in my daily life because there are so many other things I have to do, but I can write on my flights. And that's what ended up actually giving birth to 2 novels, if you like, all that air travel. The second question, what is the best advice to students on what to choose? Obviously, the cliched answer to that is follow your passion, And there is some truth in that, because was it Mark Twain? Somebody once said, if you enjoy what you do, then you'll never work a day in your life, right? Because it's all fun. So there's some truth in that. Choose a profession that you're interested in. Your heart is in it. From the age of 6, I wanted to be a physician. So that was not a difficult choice for me. However, also have a look at, since I'm talking to students here, have a look at what's out there, what's changing fast. Technology is changing fast. We're in the era of video communication. Obviously, industries that can cater to this new environment of distance learning, distance education, the ability to communicate with each other across the planet are going to do very well. The Earth is extremely concerned about climate change, global warming, and things like that. Environmental industries are going to do very well. I think healthcare will always do well, but the healthcare sector is changing because we need more innovation. We need answers to pandemics, but we also need to scale up quickly. And old ways of thinking may not work in situations where you have to scale up very quickly. Take a situation, most of the world doesn't have enough protective equipment, right? PPE and masks. So awareness of what the current problems are when carving out a career for oneself in the future, is very important. You have life sciences people on campus. We've sort of answered a lot of the questions in heart disease. Obviously, there's more of a ways to go. But if I was a young physician in my 20s now, or a young scientist, I'd be focusing on cancer and immunology, because these are 2 areas where we're barely scratching the surface. The cure to cancers, most cancers, is going to come in the 21st century. A lot of those answers are going to come from immunology, perhaps. So a focus on immunology and approaches to cancer in your more scientifically inclined students, I think is going to go a long way in problem solving for the 21st century. So think about the big problems of the 21st century, the big unanswered communication. I think we're still scratching the surface. We're getting better and better at it. Environmental issues, and then in the healthcare sector, sort of answering big questions like cancer, depression, dementia, and Alzheimer's disease, for which there are no good answers that medicine has to offer today. But hopefully in the next 25, 50, 100 years, we'd be approaching these with much greater confidence and much greater gusto, if you like.
Basu, sir?
Yeah. Once again, I have only one comment to make and one question to ask. The comment that it's simply, in one sentence, if I want to say, it's mesmerizing. Your talk has been highly motivational, tremendously powerful, dynamic, and I'm sure that not only all of us, including the students, have got a lot of things from you. You spoke about innovation, and it was rightly tackled by Dr. Yajnik, the right place. He has asked the question. As I was taking down some of the notes, I find innovation, which is the key thing for today. That is the thing you have touched very, very nicely, and people and the students will be benefited out of it. It's a terrific speech. You are such a great orator that in the beginning of the program he told. So that is one. The question, if I have to ask one question, very obvious question, because you yourself is a doctor, you said, and we can find out that you said both the right and left brain combination. So an ordinary person like us, when today we are having an extremely difficult time, as a doctor, as a right brain, as a left brain, as a combination, what is your suggestion, your recommendation to us? How we can conquer COVID?
So, it's an interesting fact. And if you talk to most neurologists, they'll tell you that we are only using small portions of our brain at a time, right? There is a huge amount of reserve in the brain that for most of us go through life without tapping it, myself included, and most of us in this audience included. So the brain has enormous potential. Now, did Einstein really have a more superior brain, or did he just use it more than all of us with his imagination? There's a great quote from him which said, imagination is more important than knowledge, right? So you can sit in an armchair, imagine, and you can bring an entire universe. I mean, the best example of that is Stephen Hawking, right? The man was in a wheelchair from the age of 30 till literally the day he died, the age of 76. But he imagined all these worlds. He imagined the Big Bang. He imagined the universe at its conception. He talked about multiverses. This is a man with an unlimited imagination, even though his physical body was trapped in a wheelchair. So I think, again, in the spirit of talking to students here, you know, you have to let your imagination go wild. You have to move into new dimensions, because these are the people who change the world, right? People with imagination that is beyond what most of us have. Take somebody like Steve Jobs, and I recommend to you some of the movies that were made out of him. This is a guy who had a concept that, you know, one day you would have a phone about this size, you know, about the size of 2 credit cards, on which you could not only make a phone call, but it's a little mini computer. There's more computing power in this than what put man on the moon, come to think of it. And this was the concept, that this was imagined by an individual when it was completely non-existent. And he took that imagination, he talked to a number of very smart engineers, Steve Wozniak being one of them, created the company, took it through to completion, and you have products that have dominated the world because of a very imaginative. Admittedly, he was a difficult man to work with. That's well known in the Silicon Valley, but he was a man with limitless imagination, and look where it has taken us today. So I think that's a good message for the students, I think. Let your imagination.
There is one question from Dr. Rajesh Jain, who's a professor at the Nirma University in Ahmedabad. Dr. Jain, would you like to ask your question, please?
What could be done to leapfrog as a nation for creating a mark in the globe, like that of Silicon Valley? Your prescription to us in general and to the academia in particular.
Yeah, so this is a good question. When I, many years ago, I was part of a group in Silicon Valley that actually talked to people coming in from other countries. And the main question we got was, how can we recreate the Silicon Valley in our countries? So for example, if you're the government of Singapore and trying to set up a Silicon Valley there, or you're the government of Abu Dhabi and trying to set it up there, or in a huge country like India, you know, with 1.2 billion people, can you create multiple Silicon Valleys? And I think it speaks to some of what Nilay and I discussed earlier. It's a culture. It's not one thing. It's not one secret. It's a culture that has to be developed. There has to be sufficient encouragement for brave new ideas, thinking outside the box. There has to be tolerance for failure. There has to be an acceptance of diversity, because different people will bring different things to the table. We may not be able to eliminate hierarchy. Our society, I know, I grew up in India, our society is pretty hierarchical, but in the context of innovation, less hierarchy is good, allowing people with bold new ideas to actually bring them forward. And I think this combination of features, I think, is what could, you know, put India up there. And there are several examples where this has already been done in industry in India, where a lot of brave concepts have come out of the Indian innovative environment. I think we just have to create that foundry in our university settings, in our company settings in India, and allow, I think, this sort of synergy between youthful imagination and, you know, the maturity of experience. It can form a good synergy to take it to the next level. You know, when Larry Page and Sergey Brin created Google, they brought in a very experienced CEO when Google reached a certain size, because they knew they didn't have the wherewithal to take it to the next level. So they brought in maturity at that level. So it's not one is better than the other. You need both. You need youth and you need experience. You need that synergy to take it to a bold new level. And universities have both by definition, right? So these things can be done on universities, campuses. Universities can be incubators for creativity. Most of the startups in Silicon Valley in the early days came out of Stanford and Berkeley and UCSF and Santa Clara University for that reason, because, you know, you had that good combination around.
And on behalf of the Navrachana University, I wish to thank you, Dr. Krishna Sudhir, for spending so much of your time with all of us It was a fascinating session, and all of us enjoyed it, students, faculty, all of us. And we had a great audience from around the world who was listening today. And we really look forward to your coming here personally, because you do visit India very frequently. And next time you visit India, please do come to our university, be our guest.
Thank you, Nilay. I enjoyed it I enjoyed it very much, and hopefully your students did too. So thank you for the invitation, and we will be in touch.
Thank you so much. Bye.
Okay, bye-bye.
And good night.
Bye-bye. Thank you.